Okay, so good morning, all of you. Good morning, and welcome on GW. It means Gate of Wallah. First of all, my dear student, just confirm audio and video in comment box. Is I am audible? Is I am audible? Okay, so good morning, all of you. Good morning, I am audible and visible and welcome on GW. It means Gate of Wallah. Tell me in comment box. First of all, my dear student, just is I am audible? Audio and video in comment box. Then we also start. Is I am audible? One of the best session. Is I am audible? Just give me. Okay, so good morning, all of you. Confirmation is I am audible? Audio and video and welcome on GW. It means Gate of Wallah. Tell me in comment box. First of all, is my dear student, just is I am audible? Audio and video in comment box. Then we also start. Is I am audible? One of the best session. Is I am audible? Just give me. Let me start. So good morning, all of you. Confirmation is going to welcome on GW. It means regarding the Gate 2020. First of all, is audible student in this session. You can say let me also start. Audible. The best plan complete subject regarding the Gate 2023. Just give me start. Good morning, confirmation welcome on regarding the Wallah 2020 in this session, you can say the best law and these questions are the most expected concepts by which please remember that it is also the best law and these questions are most respected as well as by this is my already as well as this is my already this is my this is my Is I audible? Okay, thank you, sir. So, okay, sorry for that. Actually, okay, so let me start the one of the nice session. Clear. So today I'm going to discuss one of the best 10 question from fluid mechanics and hydraulics machine. So my dear student, we are going to discuss one by one question, and please remember that each and every question is the best question. So we should maintain a proper concentration and don't mistake in calculation, especially in NAT type of question. Because if you commit a mistake in NAT type of question, you don't predict, or you can say you don't understand which answer is going to be correct or which is going to be wrong. Okay, so let me proceed the session, and we should discuss a detailed solution of step by step each and every question. Okay, so start the session, and sorry for that. Clear. So the first question is the NAT type of question, and that question is from properties of a fluid. And just I'm going to read the question first by proper one by one, and then we should see the solution in detailed way. Clear. So let me just read the question carefully. In question they are saying that 60 into 50 into 40 centimeter a block, and the weight of the block is, weight of the block is going to be 150 Newton. Weight of the block is 150 Newton. Is to move at constant velocity 1.1 meter per second on an inclined surface with an angle of inclination 30 degree. With an inclination of 30 degree. If a 0.40 mm thick oil of film with a dynamic viscosity is given as 0.014 Pascal second is applied between block and the inclined surface, my dear student, then the horizontal force, they are asking to calculate the horizontal force F needed for this motion. Clear. Should be in Newton. Please remember, the answer is we need to calculate in Newton. Clear. And you should need to calculate up to 2 decimal places. You should need to calculate 2 decimal places. In question they should given to the dimension of the block. They have already given to the weight, or you can say mg is given, that is 150 Newton, moved with at a constant velocity 1.10 meter per second on an inclined surface with an angle of inclination 30 degree. So angle of inclination is given as 30 degree. And please remember, sometimes the inclination angle is given from the vertical. Clear. But in this case, the angle of inclination is given from the horizontal surface. Clear. So if a 0.4 mm thickness film with dynamic viscosity is given as this is in MKS system, or you can say SI system, 0.014 Pascal second is applied between block and inclined surface, then the horizontal force F is needed. Clear. You should need to calculate the horizontal force which is required to sustain this type of motion. Clear. Actually block is moving on a inclined surface in upward direction. Clear. And you should calculate the how much force is required in horizontal direction, so we can maintain a constant velocity 1.10 meter per second. So it means if velocity is going to constant, acceleration is a 0. Clear? Acceleration is a 0. Clear? So first we are going to draw the free body diagram and then apply the Newton's second law of motion and balance the force. And once you get the balance equation, you should easily calculate the force which is required. Clear? And one more thing, in this type of question, clear, you should need to maintain a proper concentration, because if you once commit a mistake, then you should get a wrong answer. Clear? So let me draw the first diagram according to the question. Clear? Let me draw the diagram according to the question. Let me draw the diagram. In this question, first we should draw the diagram. So this is our inclined surface, and you can say, sir, you can say this is our block. This is our rectangular block of dimension is given. This is our block. This is our solid block. Clear? And the weight of the block is given, and this angle theta should be the 30 degree, and that angle is given from the horizontal. This angle theta is given from the horizontal. Clear? And the weight of the block is given as, let me write the weight, that is 150 Newton. And between the block and inclined surface, we should introduce a oil film. We should introduce a oil film which dynamic viscosity is given. So this is oil film. This is oil fluid of film. This is oil fluid of film. Clear? This is oil fluid of film. And the fluid is given as a Newtonian. This fluid is given as a Newtonian. This fluid is given as a Newtonian. This fluid is given as a Newtonian. And the velocity profile is mentioned that the velocity profile is a linear. So this is our first assumption is given. Newtonian oil fluid. This is given as Newtonian oil fluid. Clear? Newtonian oil fluid, and the film is linear. Velocity profile is a linear. So you should assume that linear velocity profile. The velocity profile is a linear velocity profile. Clear? And the clearance length is also given into the question. So if we draw the free body diagram of this block, and block is moving with constant velocity of v, velocity is going to be constant, and if the velocity is going to be constant, the acceleration of the block should be 0. If velocity is constant, you can say, if velocity is constant, the acceleration should be a 0. Clear? Acceleration should be 0. So when block is start moving in upward direction, block is start moving in upward direction with a constant velocity, you can say v. Velocity v is given into the question, so acceleration is a 0. Clear? But to maintain this type of motion, we should require to apply a external horizontal force. We should require to apply a external horizontal force, and you should need to determine this horizontal force. Clear? So when block is start moving on an inclined surface, so we are going to apply the no slip velocity boundary condition at the solid surfaces. Clear? So if we assume that at this surface our y is equal to 0 meter, and at this y is equal to h. Clear? And that is given into the question. And velocity profile is linear. So if the velocity profile is linear, and if you draw the velocity profile in the clearance, you get the slope of this velocity profile. Clear. Slope of this velocity profile. And what is the slope for this velocity profile? Clear. You can write du by d of y, du by d of y is, at this point the velocity is v. So you can write v2 minus ka v1 divided by y2 minus a y1. So that is a v2, it means v minus 0 divided by h minus a 0. So that is v divided by h. This is a du by d of a y. Clear? This is a du by d of y. And if we draw the free body diagram for this block, so let me draw the free body diagram for this block. So let me just draw the free body diagram. So this angle should be theta, and that angle is given. Clear? And this is the line of action of our weight, and this one is horizontal force which you are applied. So if we extend this line of action, so this is our external force. Clear? And this angle should be 90 minus theta. This one is 90 minus a theta. This angle should be the 90 minus theta. So in this direction, the component of the weight is a weight sine a theta. In this, weight sine theta, and the perpendicular of the inclined surface is, that is weight cos a theta. That is weight cos theta. And this angle should be the theta. This angle is going to be theta. Clear? This angle should be a theta. Clear? This one is a theta. And if we take the component of external force in horizontal and vertical, or you can say this is our direction of the motion. This one is direction of motion. This one is direction of a motion, and this should be the perpendicular to the motion. Clear? Or you can say this is direction perpendicular to our motion. Clear? This is perpendicular to our motion. Direction is perpendicular to our motion. Clear? So if we resolve the f external, so this angle is going to be 90 minus a theta. This angle to be 90 minus theta, and this should be the theta. Clear? This angle is 90 minus theta, and this one is a theta. Clear? So if we resolve this external force, so this component you can write f external sine theta. This one is f external sine theta, and this component should be the f external cos a theta. This component is f external cos a theta. Clear? And acceleration is 0. You can say acceleration is a 0. Okay. And when block is start moving on, you can say Newtonian fluid. So Newtonian fluid should offer a resistance opposite to the motion. Clear? Opposite to the motion. And that resistance force you can write tau multiplied by area of the surface. So in this direction, one more force will come into the picture, and that is tau multiplied by area. And this resistance force will offered by the Newtonian oil of fluid. Clear? This film will offer a resistance force that is opposite to the motion of the block. Clear? In this scenario, block is moving in upward direction, so fluid is resisting in downward direction. Clear? So if we consider the direction of the motion, so there is a three, or you can say in the direction of motion this force will acting. Clear? And this is opposite, and this is also in opposite direction. So we should apply the Newton's second law of motion in the direction of the motion. So we should apply, we should apply the NLM2 in the direction of the motion. In the direction of a motion. In the direction of motion. Clear? In the direction of motion. We should apply the Newton's second law of motion in the direction of the motion. Clear? And we should consider the direction of positive in the motion direction, and opposite to the motion, let me consider the force should be a negative in magnitude. Clear? So if we balance the forces, so F external is a positive, F external cos theta should be a positive, minus ka weight sin theta, weight or sin theta is in opposite direction, minus ka tau multiplied by area is in opposite direction, is equal to जो है is equal to a 0, because our acceleration should be 0. Acceleration should be 0. So mass into acceleration in right hand direction is completely 0. Clear? So if I should put the magnitude, let me just write F external, and the angle is given as I think 45 degree. Angle is given as 30 degree. The angle should be a 30 degree. So that is cos 30 degree, and weight is 150, clear, 150, and that is sin 30 degree minus ka tau. And for Newtonian fluid, you can write mu du by d of y, and multiplied by, you can write area is equal to 0. Clear? Area you can write a 0. So we should need to calculate our external force. So let me just put another magnitude of another parameter, sin 30 degree, and this is given as dynamic viscosity is given as 0.014. Clear? So dynamic viscosity is given as 0.014, and du by d of y is v by h. Velocity is given 1.10 meter per second. So velocity is given as 1.10 and divided by clearance. So what should be a clearance? Clearance should be the 0.40 mm. Clear? So let me write 0.40 mm. So we should multiply by 10 to the power minus 3. So that is converted into the meter. Okay. And area. What is the area of the block? Area of the block, the dimension is given as, this is our length of the block, and this is the width, and this should be the height. Clear? This one is height of the block. So the area of the contact, what is the area is in contact? Area is in contact is the length into width. This face is contact with the Newtonian fluid. This is our length, and the depth inside the plane is the width. Clear? So width into length is the contact with the block. Sorry. Okay. So where is the calculation? This one is. So the dimension is 60 centimeter into 50 centimeter. So 60 into 50 centimeter. So 60 centimeter. So we should convert 60 centimeter into meter. So that is 0.60 and multiplied by 0.50 meter. Clear? That is area is equal to a 0. Is equal to a 0. Clear? So let me just calculate the calculation. Let me just calculate what is the magnitude of the external force. So this is going to be 150 into sine of 30 degree. So this one is, let me just write F external cos 30 degree minus 75 and minus, this is 1.1 divided by 0.40, this multiplied by, you can say 1000 multiplied 0.014 and multiplied by 0.60 multiplied by 0.50. Clear? So that is 11.55 is equal to 0. So plus 75 and divided by cos of 30 degree. So our external force will come out to be, external force is come out to be 99.9393 Newton. Clear? This is our external applied force. But we should need to give the answer in up to 2 decimal places. Clear? So let me remove the other digit. So you can remove this, and this become a 4. So the correct answer should be the 99.94 Newton. Clear? the applied, or you can say the required external force, the required external force is the 99.94 a Newton. Clear? 99.94 a Newton. You should required 99.94 a Newton external force to support this type of a motion. Clear? So my dear student, I hope you should understand the solution which I have discussed in proper way. Clear? So just tell me in comment box, either you get the correct solution, or you can say you understand or not. If you not, you comment, or you can say just tell me either you understand or not. Please tell me in comment box, either you should understand the solution of this question or not. Please tell me in comment box, either you should understand or not. So the correct solution for this question is 99.94 a Newton. Please tell me in comment box, either you should understand or not. Okay, so I think you should understand. So let me move on our next question. Let me move on our next question. Let me move on next question. And second question is one of the best question you can say, that is MSQ type of question. So we should move on next question, and that question is MSQ type of question. So first we should read the question. First we should read the question carefully. In the question they are saying that if in a flow field del cross V is a 0. In the question they are saying that if in a flow field del cross V is equal to 0, then it should indicate the, clear, if our del cross V is 0, clear, is 0, then it should indicate the, and that question is one of the, you can say, best question which is from fluid kinematics. So let me discuss the solution for this question. If our curl of velocity vector is 0, clear, if our curl of velocity vector is 0, you can say, sir, our angular velocity is written as half of, you can say, del cross a V a vector, del cross V a vector. So if del cross V vector is 0, so our angular velocity is also becomes a 0, and if angular velocity is 0, you can say flow is incompressible, sorry, flow is irrotational, flow is irrotational in nature, irrotational in nature, clear, flow is irrotational in nature. If del cross V is equal to 0, if del cross V is equal to 0, you can say, if del cross V is equal to 0, omega is defined at half of del cross V. So if del cross V is equal to 0, it means omega vector is equal to 0, and that is a total omega. That is a total omega. Clear? That is total angular velocity. So flow is becomes irrotational, and we know that our verticity vector is twice of the angular velocity. Twice of the angular velocity. So that is also del cross a V a vector. Clear? And you can say, if our del cross V vector is 0, our verticity also becomes a 0. Clear? So flow is incompressible? No. Flow is incompressible when divergence of velocity vector becomes 0. Clear? Del dot V vector becomes 0. When our del dot V vector becomes 0. So the correct answer should be the B. Sorry, not B. This is rotational. So correct answer should be the C, and verticity in flow is also becomes a 0. So for question number 2, the correct answer should be the C and a D. Clear? C and D is the correct answer. A flow should be irrotational in nature, and our verticity vector is a 0. Clear? Verticity vector should be a 0. This is MSQ type of question. So you can say if the question is MSQ in nature, so more than one option will be going to be correct. And for this particular question, the answer C will be correct and D will be a correct. Clear? So I hope you should understand the solution of the question. So can I move on next question? So can I move on next question? So can I move on next question? Okay. So let me move on our next question. Move on question number 3. Move on question number 3. So read the question carefully. Question number 3 is the example of forced vertex motion, and that question is MCQ a type. This question number 4 is MCQ type. Let me just give question number. This is question number 2. This is question number 3. Okay. So this is question number 3. Clear? So this is question number 3. So read the question carefully. Read the question carefully, and that question is the example of forced vertex motion. Forced vertex motion. Clear? In question they are saying that a closed cylinder of radius 12 centimeter, radius is given as 12 centimeter, and height is given as 30 centimeter, is filled with water. So fluid is a water, and we know the density of the water. So further, if the cylinder is rotated about its vertical axis at a speed of 250 rpm, then the force exerted at the bottom cover of the cylinder should be. Please, in question they are saying that cylinder should be a closed. Cylinder is a closed. Cylinder is a closed. So top surface is closed, and the radius is given as a 12 centimeter, height is given as a 30 centimeter, and rotational speed n is given as 250 rpm. Then you should need to determine how much amount is going to be acted on the bottom of the cylinder. Clear? How much amount is going to be acted on the bottom of the cylinder. So let me first draw the diagram. Let me first draw the diagram for this question. Clear? So there is a cylinder, and this is our vertical axis, and this cylinder is rotated. This one is our vertical axis, and cylinder is a close. So let me close the cylinder, because in question they have mentioned that cylinder is closed at the top. So this one is our closed cylinder. This is closed cylinder, and the fluid is a water. The fluid is a water, and the density of the water is, we know that the magnitude of density is 1000 kg per meter cube. The density of the water is 1000 kg per meter cube, and we know that the radius is given as, the radius of the cylinder is given as 12 centimeter. So that radius is given, or you can say this is 0.12 meter, and the height of the cylinder, this is the height of the cylinder, and the height is given as 30 centimeter. This height is given as 30 centimeter. So you should write this one is 30 centimeter, or you can say that is 0.3 a meter. Clear? And rotational speed of cylinder is given as n is 250 rpm. Clear? 250 rpm. So this parameter is given, and we know that if the cylinder is closed at the top, and if cylinder is closed at the top, and if we rotate the cylinder, then due to forced vortex effect, the fluid should try to rise at the surface of the cylinder, and at the center of the cylinder fluid start a fall. Clear? At the center fluid start the falling, and at the surface fluid should start the rising. Fluid start the rising. Fluid should start the rising. Clear? I think a complete cylinder is filled with the water centimeter. Actually, cylinder is completely filled in this question. So let me just correct the diagram. Let me draw the next diagram. Actually, cylinder is completely filled. So this is the cylinder, and this one is our vertical axis, and cylinder is rotating about this vertical axis with constant angular velocity omega. With constant angular velocity omega. So this velocity should be the constant. Clear? And the cylinder is completely filled with the water. Cylinder is completely filled with the water. Cylinder is completely filled the water. So top surface is closed. This one is, you can say, this is our top surface. This one is our top surface, and you should need to determine the force at the bottom surface. You should need to determine the force at the bottom surface. Please remember that first we should, if you consider the cylinder is not rotating, then how much force is going to act at the bottom of the cylinder? That is equivalent to the weight of the fluid. Clear? If we assume that cylinder is not rotating about their axis, clear? So how much force is acted on the bottom of the cylinder? That is equivalent to the weight of the fluid above the bottom surface. Clear? So if I am consider the cylinder is not rotating, so the force is acted at the bottom is equivalent to the weight of the fluid, and once the cylinder will start the rotation, the fluid will start to rise in upward direction. Fluid will start rise in upward direction due to the forced vortex effect. But my dear student, there is a closed cylinder, so fluid cannot further rise above the top surface. Okay, so that fluid will start to develop a thrust force at the top of the surface. That fluid will try to remove the top surface, and due to the you can say rotation, a thrust will be developed at the top surface, and that thrust will propagated at the bottom of the cylinder. So in this question they should ask to calculate the total thrust force which is acting at the bottom of the cylinder. So the total thrust force which is acting at the bottom of the cylinder is equivalent to the weight of the fluid plus the forced vortex effect. You can say the force which is developed due to the rotational effect at the bottom of the cylinder. Clear? So we should remember that we have one you can say concept, the rise of the height in a forced vertex, clear, we have already read to this, ZR is equal to, that is omega square R square divided by 2Z, clear. If we consider just for example, this is an open cylinder, and if we rotate the cylinder about their central axis, clear, if we rotate the cylinder about their central axis, so let me just write, if this is our diagram for forced vertex, and this axis is our radial axis, and this one is our vertical, let's assume that that is Z axis. So at any radial distance r, you can say at any radial distance r, this height ZR should be, this height ZR should be the omega square R square divided by 2Z. Okay, omega square R square divided by 2Z. So how much a pressure will act at this point? The pressure will act P is equal to rho Z into Z, because the height of fluid is, you can say, Z. So if we write this, you can say rho Z, and the magnitude is omega square R square divided by 2Z. So this Z get cancel out. You can say rho omega square R square divided by 2. This is the pressure intensity at any location R. This one is the pressure intensity at any location R. Clear? And if we write the force according to this pressure intensity, so this pressure intensity is the variable in nature. So to calculate the force due to this pressure intensity, we need to consider a small element at the bottom surface. So we should consider a small element of thickness dr and radius is r. So this element have, you can say, thickness is dr. So what is the area for this element? The area should be the 2 pi r and dr. This is the area. Clear? So what is the force due to this? Force should be, you can write pressure intensity PR into area, that is dA. Clear? So this should be rho omega square R square divided by 2, and area should be 2 pi r into d of r. So that is, you can say, our 2 and 2 is get cancel out, and that should be the pi and r cube rho omega square and dr. Clear? That is df up p. Clear? If we integrate for a total, clear, if we integrate for total, so that total value should be the 0 to capital R. Clear? So that will come out to be the rho pi omega square r the power 4 divided by 4, and limit should be 0 to capital R. Limit should be 0 to capital R. So what is the magnitude? That is pi rho omega square, rho pi omega square, and that is r power 4 divided by 4 is in Newton. I think this will correct. Our P as a function of r is rho omega square r square divided by 2, and if you multiply it by 2 pi, that is 2 pi r into dr. So 2 get cancel out, and if you integrate this by 0 to r, you get the pressure force at the bottom. Clear? So you should calculate this pressure force. So total force should be total force at the bottom of the cylinder, total force at the bottom of cylinder is the weight of fluid plus this one, and that force is pi rho omega square r the power 4 divided by 4. So let me put the magnitude. What is the weight of the fluid above the cylinder, bottom surface? That is a pi, and volume is pi r square into h rho, clear, rho into z. This is the weight, and that is pi rho omega square r the power 4 divided by 4. Clear? And what is the value of omega? because n is given into the question. So omega is 2 pi n by 60. Omega, let me calculate first the omega. Omega is the 2 pi n divided by, you can say, a 60. So n is given to us, n is given as 250 rpm. N is given as 250 rpm. So let me just put the magnitude, 250 rpm divided by 60. So 2 multiplied by a pi multiplied by 250 divided by, you can say, 60. So that will come out to be 26.1799 radian per second. Okay, this is radian per second. R is given as, so let me just put the value. So R is given as, what is the value of R? That is 0.12, 0.12 meter, and S is given as 0.3 multiplied by rho, it means 1000, multiplied by 9.81, multiplied by 9.81, clear, multiplied by 9.81, and then the value of this is pi, let me write pi, rho is again 1000, multiplied by omega, that is 26.1799 square, and multiplied by radius is 0.12 square divided by a 4. Okay, so calculate to this value, pi multiplied by 0.12 square multiplied by 0.3 multiplied by 1000 multiplied by 9.81. So this will come out to be 133.1381 a Newton, and plus this magnitude should be the pi into, you can say, 1000 multiplied by 26.1799 square multiplied by 0.12 का square and divided by 4. Okay, let me just, where I'm going to, that is power 4. This power should be the 4. So pi, this is 1000 multiplied by 26.1799 a square multiplied by 0.12 the power 4 and divided by 4. So that will come out to 111.6226 a Newton, and plus 133.1381. So that should be the 244.76 a Newton. 244. I think I have commit the mistake. 250 rpm that is given. 244 is coming out. So where I should done the mistake. Height is given at 30 mm. So let me just cross check the calculation. See, I have put the 9.81. Height is given as this. So pi r square h rho and g, I think 2 pi n by 60, 2 multiplied by shift of pi multiplied by 250 divided by 60. So that is 26.1799. So this calculation is correct, and this is pi multiplied by 0.12 square multiplied by 0.3 pi r square h. So this is volume multiplied by, you can say, 1000 multiplied by 9.81, 133.138. So that will correct. Let me check the second calculation. So that is a pi multiplied by, you can say, 1000 multiplied by omega, and the omega is 26.1799, clear, multiplied by 0.12 raised the power 4 this and divided by 4. So that is come to out to this, and 133.138. So that is 244.760 Newton. Oh, so So that answer will be correct. That answer will be correct. That answer will be correct. Actually, this is 244. Okay. So please, this one is 244. Answer will be correct. 244.76. Actually, this is just a printing mistake. So that is 244.76. So correct answer should be the D. For this question, the correct answer should be the D. Clear? For this question, the correct answer should be the D. So this is a complete, a detailed solution for this question, and I'm expecting this year one question is coming from the forced vertex motion, and this is the best example regarding the forced vertex motion. Okay, so I think you should understand the complete solution. So can I move on next question? So can I move on our fourth question? Just tell me in comment box. Can I move on next question? Please tell me in comment box. Can I move on next question? Can I move on next question? Okay, so let me move on our next question. And fourth question of the session. So that fourth question is NAT type of question, and this question is from laminar flow. Clear? So read the question carefully. What is saying in the question? Clear? So let me just explain the question. In question they are saying that an oil of density is given as 900 kg per meter cube is being pumped in a pipe of diameter 15 centimeter. Okay, pipe of diameter 15 centimeter. The discharge is measured as 860 liter per minute. Clear? 860 liter per minute. The drop in pressure in a stretch of the 800 meter of a pipeline, both end which are at the same elevation, both end is given as at same elevation, is measured as 95 kPa. So this is given as 95 kPa. Then absolute viscosity of the oil is in Pascal second. Clear? You should need to calculate the magnitude of absolute viscosity in Pascal a second. Clear? So let me just move to this question on the board. So okay, so first we should draw the diagram for this question. So let me draw the diagram according to the question. An oil of density 900 kg per meter cube is being pumped in a pipe of diameter 15 centimeter. The discharge is measured as 860 liter per minute. The drop in pressure in a stretch of 800 meter of pipeline, both end of which are at the same elevation, is measured to as 95 kPa. Then the absolute viscosity. See, in the question they are saying that you need to determine the absolute viscosity, and the drop in pressure is given according to the diameter and the length. So we should assume that the flow is a fully developed laminar. If we assume the flow is a fully developed laminar, let me assume if the flow should be fully developed laminar. If the flow should be fully developed laminar. If the flow should be the fully developed laminar. So we can use the expression for delta P as 32 mu u mean L divided by d I square. Clear? Delta P is equal to 32 mu u mean L divided by d I square. So what is the magnitude of delta P? That is 95 kPa. So we should multiply by 10 to the power 3, and that is the Pascal. So 32 mu you should need to calculate. And what is the u mean? you mean you should need to calculate. So you mean should be the mean velocity of the flow should be the discharge divided by area. And what is the magnitude of discharge? That is 860 liter per minute. So we should convert this is in meter cube per second, and divided by area is pi by 4, and diameter is a 15 centimeter. So you can write 0.15 square. Clear? So you can write this. So if I should calculate this, so that is 0.860 divided by, you can say 60, multiplied by 4 divided by the pi, and divided by 0.15 square. So that will come out to be 0.8110 meter per second. This is our mean velocity of the flow. 860 into 10 raised to the power minus 3 divided by 60, because that is liter per minute. So 60, and you can say multiplied by 4 divided by pi, and divided by 0.15 the power this. So velocity will come out to be 0.8110 a meter per second. Clear? That is the mean velocity of the flow, and length is given as 800 meter. So that velocity is 0.8110, and length is given as 800 a meter, and divided by d square, and d is 0.15 square. Clear? So the value of dynamic viscosity from here we can easily calculate. So that is 95 into 0.15 square this, and let me calculate this, 1000 divided by 32 divided by 0.8110 this, and divided by 800. So the dynamic viscosity will come out to be 0.10295 kg per meter a second, or you can say a Pascal second. So you can say that magnitude is in Pascal second. So the magnitude of dynamic viscosity should be 0.10295 Pascal second. Clear? So I hope you get the correct answer for this. So can I move on next question? Question number 5th. So can I move on next question? So let me move on our next question. Question number 5. And question number 5 is NAT type of question from fluid dynamics topic. So first you should read the question carefully. First you need to read the question carefully, and then we should solve. In question they are saying that a water jet with a velocity of 25 meter per second is directed upward. Clear? Directed upward at an angle of 45 degree. So velocity is given as 25 meter per second, and angle is given as 45 degree from the horizontal to the horizontal. Clear? If air resistance is going to be neglected, it reaches a maximum elevation at a horizontal distance from the nozzle. Clear? Distance x from the nozzle. The value of x in meter. Clear? The value of x is in meter. So you should need to calculate the horizontal distance x at which the height of jet should be a maximum. Clear? The height of jet should be a maximum. So let me just move the question from board. Just move the question from board to board. So in question number 5, if we draw the simple diagram, we can say there is a nozzle which is placed inclined from the horizontal. This is our nozzle. Clear? This one is our nozzle, and if this one is our horizontal surface, this one is our horizontal surface. So the jet is issued from this nozzle with a velocity of V0, and that V0 is given as 25 meter per second, and this velocity is at angle of theta. Clear? This velocity is at angle of theta, and this jet should follow the projectile trajectory, and at some point, let me consider this point is at point A, and the topmost point is the point B, and this point should be the point C. So you should need to determine this length x. This is the magnitude of x. This one is the x. Clear? So you should need to calculate this value x, because at location B the y should be the maximum. Clear? Y should be maximum, and we know that the formula for this complete 2x, and that 2x will call the range in projectile motion. Clear? Range in projectile motion. So basically our x is equal to the range divided by r2. Clear? Range divided by 2, that is r by 2. Clear? If you know the formula of range, you directly put the value of r, or you can say expression for r, and calculate the x. Or you can just apply the you can say balance equation, component equation. So in this direction the velocity should be the V0 cos theta, and vertical should be the V0 sin theta. Clear? So just use the basic concept of the mechanics, or you may put the value of the r. So r is what? That is u0 square. I think that is sine 2 theta divided by, I think that is z. Clear? u0 square divided by sine 2 theta by z, and that is 2. Clear? So if we put the magnitude, of the velocity, that is of 25 square multiplied by sine 45, so that become a sine 90 degree, and divided by 2, and g should be the 9.8 of 1. So that will come out to be divided by 2 into 9.8 of 1. So that should come out to be 31.855 a meter. Clear? Or you can say x is equal to 31.86 a meter. Clear? 86 a meter. So the x should be 31.85 meter, 86 meter, at which the vertical height is a maximum. Vertical height should be a maximum. Okay? So I think you get the correct answer for this. Clear? In the question, and if you not remembering, if you not learned about this formula, you can just use a simple basic kinematic equation, and from kinematic equation you can easily calculate the value of x. Clear? Just use the component of velocity in horizontal and vertical directions. Okay, so can I move on next question? So can I move on our question number 6? So can I move on next question? So let me move on next question. So let me move on next question, and the question number 6. So first we should read the question number 6. In question number 6, they are saying that 2 points A and B are located in a long 25 centimeter diameter pipe. When a downstream valve is completely closed, the difference in pressure between B and A, P PB minus PA is 100 kPa. When the valve is open and a discharge of 70 liter per second of water is flowing, PA minus PB should be the 40 kPa. Head loss between A and B. Okay, so let me just transfer the question on other screen. Okay, so in this particular question, they are saying that 2 point A and B are located in a 25 centimeter long diameter pipe. So diameter of the pipe is given as 25 centimeter, or you can say 0.25 a meter. So that is given as 0.25 a meter, the diameter of the cylinder. So the diameter of the cylinder is given. When a downstream valve is completely closed, the difference in pressure B and A is given as this. So the PB minus a PA is given as 100 a kPa. The PA minus PB is given as 100 kPa. Clear? And this question is asked from pipe flow. Clear? And pipe, or you can say pipe and laminar flow, both topics should be important for GATE 2023. And maybe one question or two question is asked from the pipe and laminar flow. So both topics are important and crucial. So please focus on laminar and pipe flow. So PB minus PA is 100 kPa. It is given in the question. When the valve is opened and discharge of 70 liter per second is going to the pipeline, the pressure difference will become PA minus a PB, and that is a 40 kPa. Clear? 40 kPa. So head loss should be the. So you should need to calculate the HLF head loss A to B. Clear? So you should need to calculate the head loss A to B. So when the valve is closed, when the valve, please listen very carefully. When valve is completely closed, the pressure difference is 100 kPa. And when valve is open, the pressure difference is 40 kPa. Clear? 40 kPa. So just reverse the flow first, and the difference of pressure is going to be in opposite direction. So you can say the head loss is total change in pressure. So what is the total change in pressure? That is 100 kPa and plus 40, that is reverse. So you should maintain a 140 kPa pressure difference, and divided by rho into G. So the fluid is water, so you can write that is 1000 and multiplied by 9.81, and we should need to convert this kPa into Pascal. So I've just multiplied by 1000. So that 1000 is going to be cancelled, and this will become 140 divided by 9.81. So that is 140 divided by 9.81. So the HLF will come out to be 14.2711, clear, a meter of water column. So that is a 14.27 meter of water column, and the correct answer should be the A. This is in terms of water a column. This head loss is in terms of water column. The correct answer should be the 14.27 meter of water a column. When you close and open the valve, the head loss should be the 14.27 meter of water column. Okay, so please revise and focus on these two topic in fluid mechanics. One is I'm already tell you is a laminar flow, and second one is a pipe flow. Okay, so let me move on our next question, and the next question is question number 7. So we should move on our next question, question number 7. Again, question number 7 is a NAT type of question, and that is a simple question from hydraulics machine, or you can say turbo machinery, is impact of water jet on a solid surface. 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 So please read the question number 7. Read the question number 7. Read the question number 7. Jai Hind Pankaj ji. Please read the question number 7. Read the question number 7 carefully. Read the question number 7. In question number 7, they are saying that a water jet of diameter 75 mm strike on a stationary smooth flat plate normally, clear, with a velocity of 20 meter per second. 20 meter per second. And you should need to calculate the force is in kilonewton which is exerted by the water jet on the flat plate. Clear? So what is given in the question? What is given inside the question? A water jet. So the fluid is water. You can say the density of the water is 1000 kg per meter cube. The density of the water is 1000 kg per meter cube, and diameter is given as 75 mm. So diameter is given as 75 mm. The diameter is given as 75 mm. Strike on a stationary smooth flat plate normally with the velocity of this. So this velocity should be the 20 meter per second. Clear? You need to determine the force is in kilo and Newton. Clear? On the plate up to 2 correct decimal places. Up to 2 correct decimal places. So let me just draw the diagram. So here you can say this is our flat plate, and let me just place jet splitter at this, and a water jet is coming out and a strike on the flat plate. This is our, let's say, nozzle. This one is nozzle and this is a jet. Clear? Plate is stationary. So this is a smooth flat plate. This one is our smooth flat plate. This is our smooth flat plate, and this smooth plate is a stationary, or you can say static condition. In a static condition, this smooth plate is in a static condition. So when jet is strike at the center of this plate, jet splitter split this jet in 2 equal portion. You can say these are 2 equal portion. Half mass is going in upward direction, so this is m by 2, and this half mass is moving in downward direction. Clear? And this jet is a strike with velocity of vr1 and exit with a velocity of vr2. Clear? This jet is a strike with a velocity of vr1 and going in upward direction with a velocity of vr2. So if the plate is stationary, this velocity, let me assume that v1, so that vr1 is equal to v1 and that is also equal to vr2. And v1 is given into the question. So the force is the horizontal force which needed, or you can say develop on the plate. You can write that Fx on the plate is the rate of change of linear momentum, clear, of fluid, and you can say just reverse force which is acted on the fluid element. So you can write initial momentum rate, you can just write initial momentum rate minus final momentum rate. You can write final momentum rate. Initial momentum rate minus final momentum rate. Okay. So what is the initial momentum rate? Initial momentum rate is a velocity is given and diameter is given. So you can write just m dot. Velocity is, you can say, vr1, and final velocity in x direction is becomes a 0. So that is m dot into VR1. And in this problem, VR1 is equal to V1. And m dot you can write rho area of the Z and V1. This is our mass flow rate. And multiplied by V1, this will become the force. So A and rho and area should be the pi by 4 diameter of the Z square and multiplied by V1 the power 2. Clear? So let me put the magnitude of each parameter. So this is 1000 multiplied by pi divided by 4, and what is the diameter of the Z? That is 75 mm. So you can write 0.075 square and multiplied by velocity is given as 20 meter per second. So that is 20 the power 2. Clear? So if we calculate and if we divide this expression by 1000, you get the magnitude is in kilo a Newton. So this 1000 get cancel out. 1000 is get cancel out. So let me calculate this magnitude. This is pi divided by 4 multiplied by 0.075 square, and this multiplied by, you can say, 400 Newton. So answer will come out to be 1.767 kilonewton. Let me just check once more time. So this is pi divided by 4 multiplied by 0.075 the power 2 multiplied by square of the velocity, that is 400. So the answer will come out to be 1.767 kilo a Newton, or you can write 1.77 kilo a Newton. This is the force which is applied by the water jet on a flat plate, clear, in x direction. This is the magnitude of Fx. Fx should be the 1.77 kilo a Newton. This is the magnitude of the force which is going to be developed on this a flat plate. Okay, so most probably you should understand the complete solution. So can I move on next question? Please tell me in comment box. Should I move on next question? Should I move on next question? Should I move on our next question? Question number 8. Can I move on next question? Question number 8. Okay, so let me move on next question. That is our question number 8 of this session. So question number 8 is MCQ type of question, and that question is from boundary layer theory. And boundary layer theory topic is most important for GATE 2023. So please revise and do more and more practice in boundary layer theory. So this is one of, you can say, easiest question which is related to shear stress in laminar boundary layer. So let me just read the question carefully. In the question they are saying that in a laminar boundary layer over a flat plate, the ratio of shear stress are tau 1 and tau 2. Ratio of shear stress tau 1 and tau 2 at the two sections 1 and 2 at a distance from the leading edge such that x2 is equal to 4 times x1 is given by tau 1 by tau 2 is. It means they have asked to calculate, or you can say identify, the ratio of tau 1 by tau 2 in a laminar boundary layer. So let me just draw the simple diagram so you can easily understand. This is my flat plate, line diagram of flat plate. So this one is the line diagram of flat plate, and I have assumed that this is our x direction. This one is our x direction. Vertical is our y direction. This one is our y direction. And at this section, I have assumed that this one is the leading edge of the plate. This one is the leading edge of the plate. Leading edge of the plate. So x is equal to 0 meter at the leading edge of the plate, and at the end of the plate, here I have assumed that x is equal to L, and that is our trailing edge of the plate. This one is trailing edge of the plate. Trailing edge. Clear? And laminar boundary layer started from the trailing edge. Leading edge. So this is our LBL, laminar boundary layer. This is the formation of LBL. So you can say this is our laminar boundary layer. And in question they are saying that at any distance, or you can say at any section 1. So first at section 1, at this point the wall shear stress is at tau 1. This wall shear stress is tau 1. At the distance of x1. At the distance of x1 from the leading edge. Clear? From the leading edge. And at another section from the leading edge, section 2, which is x2 distance from the leading edge, the wall shear is tau 2. And you should need to determine the ratio of tau 1 by tau 2. You should need to determine the ratio of two different wall shear stresses. One at section 1, that is tau 1. Another is at section 2, that will tau 2. Clear? And we know that the value of shear stress, or you can say tau is inversely proportional to the 1 by under root x. Clear? Under root x. So if this is tau 1, you can say this is x1. This is equation number 1. And tau 2 is proportional 1 by under root x2. 1 by under root x2. So if I take the ratio of tau 1 by tau 2, if I should take the ratio of tau 1 by tau 2, that will come out to be under root x2 by x1. And each and every student know that this expression. So I'm just going to put the magnitude of x2 and x1. The relation is given as x2 is the 4 time of x1. So this is 4 time of x1, and this one is going to be x1. Clear? So x1 get cancelled out, and under root 4 is the 2. So the ratio will be 2, and the correct answer for this question will be the answer number B. B is the correct answer for this question number 8, which is MCQ type of question from boundary layer theory. Clear? One of the easiest question which you can plan from the boundary layer theory. So please revise the boundary layer theory. Boundary layer theory is the most important and most critical topic in complete fluid mechanics, which required lot of effort and practice. So if you are serious candidate regarding GATE 2023, so please practice more and more question from laminar flow. One topic is laminar flow, second topic is the pipe flow, and third topic should be the boundary layer theory. Okay, so can I move on next question of this session, question number 9? Please tell me in comment box. Can I move on next question? Can I move on next question? Question number 9. Can I move on our next question? Question number 9. So let me move on next question. Question number 9. So let me move on. Question number 9. Question number 9 is a MSQ type of question. And that question is from turbulent flow. That question is from turbulent flow. So please read the question carefully. Read the question carefully. This question is a MSQ type of question, which is from turbulent flow. And in turbulent flow, if you ask to me which topic are most important for GATE 2023, so I'm just saying that in turbulent flow, first topic which is most important is Prandtl mixing theory. Prandtl mixing theory. And in this question, I should give a brief idea regarding the Prandtl mixing theory. So don't worry. So one important topic is the Prandtl mixing theory. Second is a universal velocity profile. Universal velocity profile, which is also known as Prandtl-Kármán velocity distribution for you can say smooth pipe. And you also maybe you can say remember the velocity profile for rough pipe. So velocity profile. And next one is the Moody's diagram. Moody's diagram is most important topic in complete turbulent flow. So 2 to 3 topic is most important. One is you can say Prandtl mixing length. Second one velocity distribution, and third one is the Moody's diagram. And one more concept you should need to just go through is just how to find out the mean velocity variance, or you can say the intensity of the turbulence, magnitude of the turbulence. That is also sometime asked in GATE examination. So read the question carefully. That is MSQ in nature. Question number 9 of this session. So in this question they are saying that Prandtl mixing length in a pipe flow is Prandtl mixing length. So what is the Prandtl mixing length? Okay, see, Prandtl mixing length is just similar to the mean free path of the gas molecule. Then one student asks, what is the mean free path of gas molecule? Mean free path of a gas molecule is defined as the, you can say, average distance which is traveled by a gas molecule between two successive collision. For two successive collision, it means back to back two collision, the distance covered by the molecule will call the mean free path of the gas molecule. So what is the Prandtl mixing length? The Prandtl mixing length is defined as the distance traveled by a fluid molecule in flow field corresponding to the excess energy or excess momentum. So what do you mean by excess energy or excess momentum? See, let me consider one of the pipe. Let me just consider one pipe. This is a pipe in which fluid is flowing. This one is a pipe in which fluid is flowing. So what will happen if you remember at this y is equal to 0 meter. Y is measured from the circumference of the pipe. So y is equal to 0 meter. This y is a measure from the, this y is measured from the circumference of the pipe. From the circumference. This y is measured from circumference of the pipe. Circumference of the pipe. So y is minimum at the surface. Y is minimum at the surface, or you can say this y will be the y minimum. And at the center line of the pipe, y is equal to capital R, or you can say at the center line y is a maximum. At the center line y is a maximum. Clear? So any fluid particle in this flow field, let's say this is a fluid particle A, this one is a fluid particle, this one is a fluid, a particle, this one is a fluid particle which have some energy, and that energy is higher than the surrounding medium. So if this is surrounding medium of molecule A, if this one is the surrounding medium, this is surrounding medium of A. This one is surrounding medium of A. Clear? If this one is the surrounding medium of A and this have higher energy, E of A is greater than E surrounding. So this have some higher energy level. So due to high energy level, this molecule will start the motion. Clear? This molecule will start the motion. And let me come at some other location. Let me just come at some other location where the surrounding energy will become the equal to the energy of the molecule. This surrounding energy will become the energy of, or let's say, this A molecule, and this will be the E surrounding, and these both will become equal. Clear? Once these both quantity will become equal, the molecule is stop at this location. Clear? So the distance traveled by from this location to this location will call the Prandtl mixing length, because at this new location molecules get mixed with the surrounding, and you cannot identify which molecule is coming from the location A. Get mixed with the medium. Get mixed with the medium. Get mixed with the medium. So this molecule is get mixed with the medium. Clear? And you cannot identify which molecule start moving from point A. Clear? So the distance traveled by this molecule from this location to this location will called the Prandtl mixing length. This distance will call the Prandtl mixing length. This distance will call the Prandtl mixing length, and that length will represented by the L. This will call the Prandtl mixing length, and that length will represented by the L. So what is the Prandtl mixing length? Prandtl is related this length by K into Y, and that K is called the Karman constant. That K will called the Karman's a constant. Clear? That K will call the Karman's a constant. Clear? And the value of this Karman constant is 0.4 for our course. So L will becomes 0.4 times the Y, and Y is measured from the circumference of the pipe. Y is measured from the circumference of the pipe. So L will become 0.4 times a Y. Clear? So let me just read the option. First one, Prandtl mixing length in a flow is a constant value. No, this is wrong. So A option will be wrong. That is not a constant magnitude. Okay, maximum at the center of the pipe. I think this will correct, because Y is maximum at the center. So you can just write when Y is equal to 0, Prandtl mixing length will become 0, and that will the minimum value of Prandtl mixing length. And when Y is equal to capital R, L will become maximum, and that is 0.4 times R, and that should be the L maximum. That should be the L maximum. Clear? So that will become maximum value. That will become a maximum. So in B, maximum at the center of the pipe. Maximum at the center of the pipe. So B option will be a correct. So B option will be correct. C will be 0 at the wall of the pipe. 0 at the wall of the pipe. Okay. So at the circumference of the pipe, Y is 0. So at the wall, the shear is Prandtl mixing length become a 0, or you can say minimum. So this is also correct. C is also correct. And maximum at the wall surface, no, this is wrong. Minimum at the wall surface. So for question number 9, which is a MSQ type of question, the correct answer should be the B and a C. The correct answer should be the B and a C. For this, the correct answer is B and C. Clear? Question number 9 have correct answer is B and a C. So please tell me in comment box either you understand or not. Please tell me in comment box, are you understand? Are you able to understand this concept of parental mixing length? Please tell me in comment box, are you understand or not the concept of parental mixing length? Okay, so I think you should understand the concept. So let me move on our next question and last question of this session, that is question number 10. So let me move on our last question, question number 10. So please read through this question carefully. That question is again MSQ type of question, which is taken from buoyancy and meta center. That question I have taken from buoyancy and meta center. So please read this question carefully. Read this question carefully. Again, that question is MSQ type of question. Read this question carefully. This is last question of the session. Read this question carefully. So let me just explain the question. In this question they are saying that a solid cylinder of a diameter 30 centimeter. So diameter is given at 30 centimeter, or you can say D should be the 0.3 meter. 0.3 meter, and height is 15 centimeter, float with its axis vertical in sea water. Relative density is given as 1.03, and if the relative density of the cylinder material is 0.9, which statement should going to be correct? So you should need to calculate our metacentric height, that is you can say GM, that is also you should write the GM, and you need to determine which type of equilibrium for this condition. Either cylinder is in stable equilibrium, or in unstable, or maybe is in neutral equilibrium. So please read the question once more and try. Please tell me in comment box. Try the question carefully. Try the question carefully. Try the question carefully. And tell me the answer in comment box. Please read the question carefully and tell me answer in comment box. Okay, so let me calculate. I hope you should read the question carefully. So in this question, first we should draw the proper diagram so you can understand what is asking in this particular question. So there is one cylinder, you can say this one is our cylinder, which is floating in a liquid medium, which density is given into the question. So this is our cylinder, and let me assume that this one is our free surface. So this is Z is equal to 0 meter. Z is equal to 0 meter. And the diameter for this cylinder should be 30 centimeter. So you can say 0.3 meter. Diameter is given in 0.3 meter. and this height is given as 15 centimeter. So that height should be the 15 centimeter. So this one is height. And if I should assume the depth of submergence of the cylinder is a y, this depth of submergence is, we should assume this is y, and at the bottom face we should consider this point is O. Let me consider this is the point O at the bottom of the surface. Clear? This is point O. Then there's a two different force. One is the self weight of this cylinder, which is acting on the center of gravity of the body. So that is a weight. And another force is the buoyancy force, which is acting due to the medium of the fluid. And the application of buoyancy force is the center of buoyancy. So center of buoyancy is the center point of, or you can say CG of the displaced fluid element. So where is center of buoyancy? Somewhere this. This is our CB point. And this value is y by 2. Clear? This value should be a y by 2. And this CG height is L by 2. Or you can say h by 2. This is h by 2. This is going to be h by 2, and this is y by 2. So from this y by 2, a buoyancy force will act. From this, a buoyancy force will act. That force will be the F of B. Clear? When buoyancy force is acted, that is FV. So there are two different concepts. One is, you can say, concept of flotation, and another one is a concept of stability. So first we are going to use concept of flotation. So using concept of flotation, flotation, if I should use the concept of flotation, so according to this, if body is floating in the medium, you can equate Fv is equal to weight of the body. So that Fv is exactly equal to the weight of the body. That Fv is equal to the weight of the body. So what is the Fv? Fv is the weight of displaced fluid. That is equivalent to weight of displaced fluid. That is equal to a weight of displaced fluid. This one is weight of displaced fluid. So how much weight of fluid is going to be displaced by this cylinder? That is equivalent to the cylinder which is submerged inside the fluid medium. So the dimension of a cylinder which is submerged inside the fluid medium is, if I assume that this surface area is A, if I will assume this surface area is A, so you can write A multiplied by Y is a volume which is going to be displaced by this cylinder. So this is A into Y, rho of the fluid into Z is equal to A multiplied by 15, volume of the body multiplied by rho of the body multiplied by Z. So Z is going to be cancel out, A is cancel out, and here you can say write Y multiplied by rho of the fluid. So the relative density of the fluid is 1.03. So that is 1.03, and the density of the body is 0. I think 9. This is cylinder of material 0.9. Okay, 0.9. So what is the value of Y from here? That is 15 multiplied by 0.9 divided by 1.03. So that will come out to the 13.1067 centimeter. This is in centimeter. The value of Y is in centimeter, and that value should be the 13.1067 a meter. This value is in centimeter. Okay, this value is in a centimeter, that is 13.1067 a centimeter. Okay, so we should get the value of Y. we should get the value of y. So that y is 13.1067 centimeter. The value of this y is 13.1067 centimeter. Okay, so let me use the concept of stability, and before moving on concept of stability, we need to determine the value of bm and all the things. So somewhere you can say there is a meta center point m. Clear? I'm just projecting the meta center on a vertical axis. I know if you rotate the body, then buoyancy will displace from the axis and meta center will come into the picture. Okay, so I'm just assuming that I have rotate the body by a very small angle at theta, which is almost negligible, and due to rotation the meta center will be developed, and we should just extract the meta center from this some other point on a axis of the body. Okay, so the value of metacentric radius, that is bm is I, moment of area, divided by displaced volume. So what is the I? I is the moment of area in plane and minimum moment of area, which plane is contact with the free surface. So in this problem, this surface is contact with the free surface, and that is a circular plane, and we know that the moment of area for a circular plane is pi by 64 by multiplied by d to the power of 4. So I is pi by 64 multiplied by d to the power 4 and divided by displaced volume. So what is the displaced volume? That is a pi d square by 4 and multiplied by depth of submergence, that is y. So, and that is a bm. So pi get cancel out, this d and this has become d square. So this is cancelled, that is 16 become a 16. So remaining term is d square divided by 16 and multiplied by y. Okay, so let me put the magnitude in centimeter. So what is the value of diameter? Diameter is a 30 centimeter, I think. So that is 30 centimeter square divided by 16 and multiplied by 13. 13.10 pi r square d 1067. So what is the magnitude from here? That is 900 divided by 16 multiplied by 13.1067. So that will come out to be, 900 divided by 16 into 13.1067. That will come out to be 4.291698 a meter. Centimeter, not meter. That is in centimeter. This is the value of bm. This will be the value of bm. So this value I have calculated. This value is I have calculated. This bm is come out to be, this bm is comes out to be, this value should be the 4.29169 centimeter. Okay, this bm will be come out to be, this bm will be come out to be 4.29169 a centimeter. Okay, so let me calculate the value of this bg. So this value is a bg. So we should need to calculate this value, and this one is the bg. So if we subtract bg from the bm, you get the metacentric height gm. What is the value of gm? Gm should be the bm minus a bg. Bm minus bg. Okay, so bm I have already calculated, that is 4.291609 minus a bg. What is the value of bg? Bg is that bg will be the half of 15, that is 7.5 minus y by 2. And what is the value of y by 2? Y by 2 become 13.1067 divided by 2. 13.1067 divided by 2. That is 6.55335 centimeter. Okay, 33 centimeter. So what is come out to be? Minus 7.5. So that will come out to be, this is 4.29169 minus 0.9466 This will come out to be, and if we subtract this value, 9169 minus this, so our GM will come out to be the 3.345 centimeter. This metacentric height should be come out to be the 3.345 centimeter. So this should be our metacentric height, and that height will be a ZM. This is our metacentric height. That height should be the ZM. Okay. So metacentric height should be, in this case, metacentric height should be 3.345 a centimeter. So first answer should be the A. Our metacentric height is 3.34 a centimeter. And which type of equilibrium? If we know that if our metacentric height ZM, is positive, then we can say stable equilibrium. If metacentric height is positive, then you can say stable equilibrium. If metacentric height is 0, you know that the condition is neutral equilibrium. The condition should be neutral equilibrium. And if our ZM is less than 0, you can say the condition is unstable. Okay. In another way, you can say if our metacentric point is above the center of gravity, clear, then body is in stable equilibrium during the floating conditions. And if our metacenter is 0, exactly 0, then body is in neutral equilibrium. And if our metacentric point is below to the center of gravity of the body, in this condition you can say body is in unstable equilibrium. Okay, so here we get the value of metacenter is 3.34 centimeter. It means our value of ZM is a positive. Our value of ZM is a positive. So if the value of a ZM is a positive, you can say, sir, the condition is stable in nature. So the correct answer is A and C. For this question, the correct answer is A and C. Okay. Metacentric height is 3.34 centimeter, and condition is in stable in nature. Okay. So I have discussed one of the best 10 question from different topic, including complete fluid mechanics, as well as one question from turbo machinery. And I hope you should enjoy to this session. And I'm just say one thing. If you're serious for GATE 2023, remember that fluid mechanics have a lot of weightage, and you just need to put a maximum concentration during your calculation. And you can say just reading the question, identify the data, which data, or you can say which parameter is given into the question, in which unit you should need to calculate or need to give the answer. So these a small thing will required in examination, and I hope you should already aware from these particular point. So I'm just saying that all the best for your examination, and prepare seriously. If you get selected and get good rank, then you can say maximum one of the best public sector is waiting for you. So my dear student, thank you and best of luck.